So now that we've determined what it takes to make a triangle and what's the relationship between the angles and the sides of a triangle, we're going to talk about the different types of triangles. Now, most of these shouldn't be reviewed to you, so I'm going to kind of buzz through the classifications really quickly, and if you need to pause it, then pause it so that you have time to write things down. So scalene, that's how you would say that. Scalene means that all three sides are different. So AB is different from BC, which is different from AC. Isosceles means that at least two sides are congruent. So in this case, DE is congruent to EF. E is called the vertex angle, and DF is called the base. So that means that angle D and angle F are called the base angles, and they are congruent to each other. We'll talk more about that. Or we did yesterday when we looked at angle side relationships. If you notice that when you had two sides the same, then the two angles had to be the same because the smallest side's across from the shortest the smallest angle, and the longest side is across from the largest angle. And when they're the same, they have to be the same. Equilateral triangles, equilateral, equal sides, means that all three sides are congruent. So LM and MN and LN are all the same size. Now, that would tell you then that also that all of these angles are going to be equal, and we'll talk about that in just a second. So if we want to classify by angles, we would call it acute, obtuse, right, and equiangular. Acute means that all the angles are less than 90. Obtuse means that one angle is greater than 90. Only one angle can be greater than 90 because the other two have to be smaller because all three angles of the triangle add up to 180. A right triangle has one 90-degree angle. AB is the hypotenuse. AC and BC are the legs. And then an equiangular triangle, equa means equal, angular, angles, means all three angles are equal. Well, if all three angles are equal, all three sides are equal. So equiangular and equilateral are the same, right? So if you call it by its sides, it's equilateral, but call it by its angle, it's equiangular. But an equiangular triangle is equilateral and vice versa. Another word for that is regular. When a shape is called a regular shape, it means that all the sides are congruent to each other and all of the angles are congruent to each other. Okay? So, if I want to classify these by its sides and its angles. Now notice, I didn't give you any of the sides, but that's okay, because based on what we learned about angle-side relationships, we're going to know what the sides are, or not what they are. We won't know their lengths, but we will know them in relation to others. So when we have all three angles equal, okay, that means that all three sides have to be equal. So that means it is equilateral, classified by sides, and it is equiangular, classified by angles. Then scalene. Scalene means all the sides are different. So this is scalene because if you look, all the angles are different, which means that all the sides have to be different. So classifying it by its sides would mean that it's a scalene triangle. And all of these angles are less than 90 degrees, which means that that angle is, or that triangle is an acute triangle. Okay, then we have this one. So if you look, all three angles are different. So to classify it by its sides, it would be scalene. If all the angles are different, all the sides will be different. And it is a right triangle because we have one right angle. And then this one, notice that we have two angles that are the same and one angle that is obtuse. That means that this triangle is isosceles because two sides are congruent. Two angles are congruent means that two sides are congruent. And it is obtuse because it is a 128-degree angle. Now, let's look at some of these on a grid, coordinate geometry. Determine whether each triangle is scalene, isosceles, or equilateral. So we want to classify it by its sides, and we want to tell if it's a right triangle. Now, in order to tell if it's a right triangle, what we want to think of, especially when it's on a grid, what we're looking for is, are they perpendicular slopes? Are they opposite reciprocals? Okay, that's what we're looking for. So first, let's calculate. I'm going to show you the long way to do it, then I'll show you a shorter way to do it. Let's calculate the distance from B to F. So the distance from B to F, let's label these first. We can use the distance formula. You can also use Pythagorean theorem, but we'll talk more about Pythagorean theorem later. So F is at 5, 6, B is at negative 1, 4, and H is at 1, negative 2. Here's your x-axis right there. It's kind of hard to see. Okay, so distance formula would be BF. So BF, the distance formula, remember, is x minus x squared and y minus y squared. Okay, if you write your skeleton, write your equation, the bone of your equations, right, the bones of your equations, then you've got y minus y, so 6 minus 4, and then 5 minus a negative 1. Okay, now type all that on your calculator, and you get that BF is 6.3. We'll talk about simplifying radicals in just a couple of days, but for right now, I just want to know, I just need to compare them in length to be able to see what they are. FH, so if we do FH, same thing, we need to do the distance formula. We're going to write the skeleton of our equation, then we'll just type it into our calculator. So FH goes 6 minus a negative 2, and 6 minus a negative 2, and 5 minus 1. And so when you type that into your calculator, you get that FH is 8.9. And then BH, same thing. Substitute in your numbers. So BH, 4 minus a negative 2, and 1 minus a negative 1. Type that into your calculator, and you get that BH is 6.3. So right now, you can classify it by its sides. I don't know anything about the angles. I have no way right now to know anything about the angles. Therefore, we have to know the side lengths in order to classify it by its sides. That's why I did all that work. Okay, so classified by its sides, I have two sides that are the same, which means that this is an isosceles triangle. So classified by its sides, it's isosceles because two sides are the same. Now, the question is it a right triangle? So for it to be a right triangle, we need two that meet up at a right angle. To be at a right angle means they are perpendicular. Well, on a graph, we can do perpendicular by opposite reciprocal slopes. So the slope of BF, rise over run, would be 2 over 6. So the slope of BF is 2 over 6, which is 1/3. The slope of BH, right here, BH, so rise over run would be rise over negative 2, 6 over negative 2, which is negative 3. Already, look right there. Now, if I had happened to do FH first, then I might not have caught all three of them. But look, if there can only be one right angle, and these are opposite reciprocals, right? One's positive, one's negative, 1 over 3. The reciprocal of 1 over 3 is 3 over 1. So those are indeed right angles. So those are perpendicular. So yes, this is a right triangle. There's only one right angle, so there's no reason to even check it. Now, I know it looks like it, but you still need to check it unless you can see like they're horizontal and vertical and it's easy to see that they're perpendicular. You need to test it because 89 degrees is pretty close to 90 degrees, and to the eye, you may not be able to tell the difference. Now, a little bit shorter of an option for this is to tell if it's a right triangle, we need the slopes. And I'm going to use those slopes. Now, notice your scale. Here's your x-axis right here. Notice your scale counts by 2s, 2, 4, 6. So it would be up 1, and then it's 2, 4, 6, 8, 10, 12, 13. So the slope of BA is negative 13 over 2. Oh, I said that backwards. Sorry. Negative 2 over 13. Rise over run, not run over rise. See, I can make mistakes too. We all do it. And then the slope from C to A, so up and over, so 2, 4, 6, 8, 10. So the slope from C to A is 10 over 2, 4, 6, 8. So 10 over 8, which is 5 over 4. And then the slope from B to C, rise over run, would be 2, 4, 6, 8, 10, 12. Let me see. So 12 over negative 2, 4, 5. So as you can see, none of those slopes are the same at all. They're all completely different. There's no opposite reciprocals, which means that this is not a right triangle. Now the other benefit to this is that I don't even need to do the distance formula, because since none of these numbers are the same, 2 and 13, 12 and 5, 5 and 4, since none of those numbers are the same and they can't be reduced anymore, that means that none of those sides are going to be the same length. Later when we learn about Pythagorean theorem, you'll see that. But since none of those are the same, then there is no way that those sides can be the same. Okay, none of the numbers are the same. So classify by sides, it has to be scalene. No sides are the same. All right, last one. Now this one's a little bit tricky. You have to be careful, and so you might want to draw a picture when you see it kind of over here before you put it over here. So triangle ABC is an isosceles right triangle. So two sides are the same and there's a right angle. So isosceles right triangle. So let's draw what that means. So an isosceles right triangle looks like this. Okay. Now it says find C, angle C, or find the point. I want the location of C if AB is equal to BC. So these two, these are AB and BC. They share a B, so the B has to go in the middle. Now why that's important is because that's where the right angle is. So this is AB and then that's BC. So that just gives me an idea of what it's going to look like on the graph so that I can figure out where C goes. So A is at negative 2, 1. There's A. And B is at 1, 5. There's B. So A to B. Now, A to B needs to go to B to C. So BC needs to be over here, right? That's one direction that BC could go, would be this direction right here. Now, they're going to meet at a right angle. Right angles, opposite reciprocal slopes. So it would go up and over, up 4 over 3. Okay? So the slope of AB is 4 over 3. So the perpendicular slope, the slope of BC, would be negative 3 over 4. So from B, let's go down 3 and to the right 4. 1, 2, 3, 1, 2, 3, 4. So that is one possible location, right? Because that gives us that triangle right there. Those two are the same because it was 4 and 3, and then 3 and 4, same numbers. And so they're the same length. So those two are the same length. So we could say that C is at 5. Nope, C is at 5, 2. However, there's one other way we could go too, right? We didn't define which direction, so we could also go this way, right? So instead of going down 3 and to the right 4, we could go up 3, 1, 2, 3, and to the left 4, 1, 2, 3, 4. So another possible location for C could be right there. So another possible location would be at negative 1, 2, 3, positive 6, 7, 8. So that's another possible location, okay? But since B had to be right there, that has to be the right angle, so we have that right triangle possibility. We also have that right triangle possibility, okay? So we have classifying by sides. We have scalene, isosceles, and equilateral. Classifying by angles, we have acute, obtuse, right, and equiangular. And we bring back our old friend of opposite reciprocals, our perpendicular slopes. So we'll use that again, so keep that in mind. And we can tell whether they're right triangles by telling if their slopes are opposite reciprocals whenever the problem is on a grid.